Okay, today we're going to go over clearing an equation of fractions. Sometimes that is called fraction busters. So we're going to talk about clearing equations of fractions. So look at this problem and look at all those fractions in there. You could actually deal with the fractions and we could subtract 2 from both sides, and then we'd have to get, work with all those fractions, and we certainly could do that. But we're going to use a technique to clear the fractions, and we're going to call it fraction busters. So we're learning the technique of getting rid of all those fractions, which is called fraction busters. Pretty cool technique. Good to have in your toolkit of things to do. So before we do that, let's just practice multiplying a whole number times a fraction. So remember, you could put a 1 underneath the 12, and then we could say 4 goes into 12 3 times, and then 3 times 3 is 9x, right? So we could put a 1 underneath the 24 and say 6 goes into 24 4 times, and 4 times 5 is 20. We could put a 1 underneath the 18 and then say 6 goes into 18 3 times, and then 3 times 3n is 9n. Right, so just reviewing how to multiply fractions with a whole number. So that is called cross-canceling. That's different than cross-multiply. So remember, with proportions, right? Proportions, we did what's called cross-multiply. And when you're multiplying fractions, right? When you're multiplying fractions, unknown caller, you can do cross-canceling. Okay, so when you're cross-multiplying, that's when you're cross-multiplying, but we are cross-canceling. We're saying 9 goes in 18 twice, so that's different. So I just wanted you to see the difference between those two. Okay, so if we have 16 over 1, we can say 2 goes into 16 8 times, and then 8 times 1x is 8x. We can put a 1 underneath that and say 6 goes into 12 twice, and then 2 times n is 2n. And 3 goes into 9 3 times, and 3 times 1 is 3, and then those are n's. Okay, looking at finding the lowest common multiple. So we have to be able to find the lowest common multiple between 3 and 9. So we're going to list the multiples of 3, and we're going to list the multiples of 9. And we're going to see that's going to be the multiple lists. And so basically you're just counting by 3. So 3, 6, 9, 12, 15, 18, etc., right? That's your multiplication facts, or your multiples of 3. You're counting by 3s, and then we're going to count by 9s. So 9, 18, another 9 would be 27, another 9 would be 36, and so on. And then we want to see where they're common. So they're common here, and they're also common here, and they're common other places, but we want where they're the lowest. So this is considered the LCM. So 9 is considered the lowest common multiple, because this is where they're common, and this is where they're the lowest common multiple. So we say the LCM is 9. So that's how you find the lowest common multiple. So let's try another one. So the lowest common multiple of 3, 4, and 6. So we're going to make a list of the multiples of 3, we're going to make a list of the multiples of 4, and we're going to make a list of the multiples of 6. So counting by 3s, 3, 6, 9, 12, 15, 18, 21, and so on and so forth. 24 and 27, right? We keep on going. List of multiples of 4 means we're counting by 4s. So 4, and then another 4 would be 8. Add another 4 would be 12, 16, 20, 24, and so on. And then multiples of 6, we're counting by 6s. So another 6 would be 12. Add another 6 would be 18. Add another 6 would be 24, etc. And we want to see where they're common. So as soon as you see where they're common, like if you notice they're going to be common here at 12, then you really don't need to write all this, right? As soon as you see, if you can see that the lowest common multiple is going to be 12 without making your list, that's fantastic. That is fantastic, right? So if you can see it's going to be 12 without writing the entire list, then that's what we want. That's what we want to see. So let's look at the next one. So the next one, we want to find the LCM of 4, 6, and 8. So we are going to make a list of multiples of 4, multiples of 6, and multiples of 8. So when we're counting by 4s, that would be 4 and 8. Count another 4 would be 12 and 16 and 20 and 24 and 28 and so on and so forth. And then multiples of 6, we're counting by 6s. So 6 and then 12 and then 18 and then 24 and then 30, 36, etc. And then now we're going to count by 8s. So 8, add another 8, add another 8, add another 8, add another 8. And again, I want to stress, if you can see that they were going to be 24 was where they're going to be common, then you really didn't have to write all that list. Like if you can see it without actually writing out your lists, then that would be fine. So here's sometimes what I do as a shortcut, because that's like a lot of work. So as a shortcut, here's what I do, is I pick the biggest number, right? So this is my shortcut technique. I pick the biggest number, which is 8. And I start doing my multiples of 8. So I start off and I say, does 6 go into 8 evenly? No. Does 4 go into 8? So I go to the next one. Add another 8. Another 8 would be 16. Does 6 go into 16 evenly? No. I add another 8, which would be 24. Does 6 go into 24 evenly? Yes. Does 4 go into 24 evenly? Yes. Then 24 is going to be my LCM. So let's try that shorter version technique with, go back to number 8, and let's try that shorter technique with number 8. So with number 8, we're looking for multiples of 3, 6, 3, 4, and 6. So the shorter technique is I'm going to pick the 6, and I'm going to make multiples of 6. Does 4 go into 6 evenly? No. Then what's the, add 6 more, 12. Does 4 go into 12 evenly? Yes. Does 3 go into 12 evenly? Yes. Then 12 is going to be our multiple of 3, 4, and 6. So that's a little bit of a shorter technique. Okay, so now we're going to use the multiplying by the lowest common multiple to bust up our fractions. So in problem number 10, we're going to use the technique of clearing the fractions by doing what we call fraction busters. Right, so we're going to clear this of fractions so that we don't have to work with all those fractions by multiplying everything through by the LCM. So I'm going to multiply every single one of these. So I'm going to multiply every single term by the LCM. And so we have to figure out what the LCM is going to be. So we want to know what the LCM is going to be, and that's what we're going to multiply. So we're going to look at the denominators. So look at the problem, and what are the denominators in the problem? There's a 3 and there's a 9 are the denominators. So I need to find the LCM of 3 and 9. So I need to make my list of 3, and I'm going to make my list of 9. So 3, 6, 9, 12, etc. And 9, 18. I can stop because I can already see that 9 is going to be our LCM. So 9 is what we're going to multiply everybody through by. So 9 is our LCM. If you can already see, so basically we're just looking for, what number can 3 go into evenly and what number can 9 go evenly. That would be the lowest, right? So if you can see that without doing all that work, because you can see it in your head, good for you. So let me do a little bit of erasing, kind of clean this up a little bit. So now we're going to multiply 9 to every single term. So we're going to multiply 9 to 1/3 x. And then I'm going to recopy my plus, and then I'm going to multiply 9 times 2, and then equals. And I'm going to multiply 9 again times -3/9. So notice I'm multiplying 9 to each one of these terms. And then like we did at the very beginning, we just multiply fractions. So when you multiply these two terms together, can't we say 3 goes into 9 3 times? And then 3 times 3 times 1 gives me 3, and those are x's. And then obviously 9 times 2 is 18, right? When you multiply those two, equals. And then we're going to say 9 goes into 9 once, and then 1 times -3 gives us -3. See? No more fractions. So by multiplying through by the LCM, it gets rid of the fractions. It clears the equation of fractions. And then we're like, oh, we can handle this. right? And then we can finish up the problem by subtracting 18 to both sides. So that's negative 21, and then divide both sides by 3. And I'm running out of room, so I'm just going to say my final answer is negative 7. Right? So when you have a bunch of fractions in a problem, I like to use fraction busters to clear the equation of fraction busters. And we do that by multiplying every single term by the lowest common multiple, the LCM. Let's try another example. So again, you might want to try pausing the video, and you could go back and even try the problem that we just did. So let's try number 11. So the first thing I do is I look at the denominators. And I only need to focus on the denominators. So I want to multiply the whole entire equation by the lowest common multiple. So I'm going to multiply everybody, and that's what you show. So don't forget to show that parentheses around the whole equation, because that's the correct notation, and we want to multiply by the lowest common denominator, which of course would just be 7. So I'll put that in red. So that would just be 7. So we're going to multiply every single term by 7. So that would be 7 times h plus 7 times 1/7, and then 7 times 3/7 h. So I'm just showing that I'm going to multiply 7 times each one of those. And then now we're going to actually do it. So when you multiply 7 times h, doesn't that just give you 7h? Plus, and then can't I cancel and say 7 goes into that 1 time? So doesn't that equal 1 times 1, which is 1? And can't I say 7 goes into 7 once, and then 1 times 3 gives me 3, and don't forget those are h's. See, no more fractions. Right? Now we have to solve the equation. I notice that this equation has variables on both sides of the equation. And I have already, all the variables are already on this side. So wouldn't it make sense to subtract 7h from both sides? Because that would give me, that's 0 h's, and that gives me just 1, and then I get negative 4h on this side. So I have all the variables on one side and all the constants on the other. Then I can undo multiplying by negative 4 by dividing, and that gives me h equals negative 1/4. Okay, now let's look at number 12. So we want to just focus in on the denominators, and the only denominators are 3 and 4. So we want to find the LCM. So we need to make a list of 3's, multiples of 3, and multiples of 4. So again, if you can see, I always pick the biggest number, and I just go 4 is 4, 3 doesn't go into 4, and then 8, 3 doesn't go into 8, and then 12, okay, 3 goes into 12, so 12 is going to be my LCM, right? 3, 6, 9, 12, 15, right? 12 is going to be your LCM. If you can already see the LCM, good for you. So basically we're thinking of a number that 3 will go into evenly and 4 will go into evenly, which is the lowest. So 24 is a good number that we could multiply, because 3 goes into 24 and 4 goes into 24, but it's not the lowest. So we really want to pick the lowest common multiple. So 12 is going to be the lowest common multiple. And we're going to multiply 12 to every single term, right? So we're going to distribute and multiply 12 to every single term. So we need to multiply 12 times x over 3. And then we got to multiply 12 again times 3/4 x. And then we have to multiply 12 again times negative 3. So don't forget to multiply this guy by 12 as well. Everybody always ends up forgetting this guy. So every single term has to be multiplied by 12, right? And then let's go ahead and multiply. So I can put like a 1 underneath that. So I can say 3 goes into 12 4 times. And then 4 times x is 4x. And again, I can put a 1 underneath that. And I can say 4 goes into 12 3 times. And then 3 times 3x is 9x's. And then 12 times negative 3 is negative 36 when I multiply those two. Right? See, no more fractions. So by multiplying through by the LCM, you clear the equation of fractions. Hence, fraction busters. Right? And then I notice we have like terms. Both of these are like terms, so I can combine them because they're on the same side. Nike, just do it. You don't show any work for that. You just actually put them together, right? And then I've got all the variables on one side and the constants on the other. So I can undo multiplying by 13 by dividing by 13. And that gives me x equals negative, because a negative divided by positive is negative, and 13 times 2 is 26. 13 times 3, nope, that's just going to be a fractional answer, and it cannot be reduced, so that is my final answer. Okay, multiplying through by the LCM clears the fractions of fraction, hence fraction busters. So let's try another one. This one looks like a doozy. So again, the first thing we want to do is we want to focus on what are the denominators in the problem. So we want to kind of emphasize what are the denominators in the problem. And we want to find the LCM. So to find the LCM, we are going to make a list of our multiples of 4, multiples of 8, multiples of 6, and multiples of 8. And that can take a lot of time. So the shortcut is just to pick the bigger denominator, and let's make multiples of 8. So 8, does 6 go into 8? No. What's the next multiple after 8? So add another 8, that would be 16. Does 6 go into 16? No. Add another 8 is 24. Does 6 go into 24? Yes. Does 4 go into 24? Yes. Then 24 is going to be our LCM. So we're going to multiply this entire equation by, so we're going to multiply 24 to every single term. Remember, every term has to be multiplied, right? So we're going to multiply 24 times 3/4, 24 times 2/8 n, 24 times 1, and 24 times negative 5/6, right? Because that is our LCM in this problem. So let's show what we're going to do. 24 needs to be multiplied to 3/4, and there's a subtraction, so I'm recopying the subtraction. And then 24 has to be multiplied times 2 over 8n, and then there's an equals. And then 24 has to be multiplied by 1, right? So now we're here, and then there's a minus sign, and then 24 has to be multiplied to the last term, which is 5/6n. Right? So now we're going to do that. So we're going to multiply 24 to each one. So I can put a 1 underneath this, and I can say 4 goes into 24 6 times. 6 times 3 is 18. Put a 1 underneath that, and 8 goes into 24 3 times. 3 times 2 is 6, and don't forget those are n's, right? Don't forget you have a variable n there. And then 24 times 1 is just 24. And then there's a minus, right? And then we can say 6 goes into 24 4 times. 4 times 5 is 20n. Okay, so see, no more fractions. That's what's so pretty cool about this. Instead of, when you have all those fractions, if you just multiply through by the LCM, see, no more fractions. Yay! Right? So now we can finish solving the equation using your skills of algebra of solving equations. And I notice that I have n's on both sides of the equations. So I want to undo one of the sets of n's. It doesn't matter which one. So I guess I'll add 20n to both sides. And there's lots of different ways that you can do these particular steps. So there's 18, and a negative 6n and a positive 20n would be a positive 14n's. And then 24, negative 20n and plus 20n is no more n, so I just have the 24 on that side. Then I can subtract 18 from both sides. And that's going to give me 14n equals positive 6, because I have more positives than negatives. And then I can undo multiplying by 14 by dividing by 14. And my answer is going to be 6/14. And if you can reduce, you should always reduce. And it looks like 2 goes into both of those, so I can reduce by 2, which means I'm dividing top and bottom by 2. So 6 divided by 2 is 3, and 14 divided by 2 is 7. So 3/7. So the expectation is that if your fraction can be reduced, you should always reduce your fractions. Okay, so that's Fraction Busters. Multiplying through by the LCM clears the fractions, and you have no more fractions, which makes us really happy. And then we can just finish solving from there.